This video will cover the third page of notes on the topic of rational equations. Let's solve one more problem. For example number 3, our job is to solve 7 times x to the negative 4 minus 8 times x to the negative 2 plus 1 is equal to 0. So the very first thing I'm going to do is I'm going to rewrite these negative exponents. When we do that, we're going to see that we're going to have 7 over x to the 4th power. Remember that the negative 4 is only affecting the x. That's the reason why the x to the 4th power is in the denominator. The 7 still has a positive exponent, so it still stays on top. That positive exponent of 1. Same thing happens here. The 8 has a positive exponent of 1, so it stays at the top. And x to the negative 2 becomes x squared in the denominator. So notice this also becomes a rational equation to solve. So let's start off with step 1, which is our domain restrictions. We look at every fraction that we have, and we set the denominator equal to 0. And we're going to see that x is equal to 0 will cause this first and this second fraction to be undefined. So our restriction is that x cannot equal to 0. Now let's number 2, which is to find the LCD. And again, we can see that if we go through each of our terms and we see how we can get rid of the denominator, that will help us find our LCD. Notice the 1 here doesn't have a denominator, so it doesn't contribute. This one needs x squared. Well, if I do an x here, then this one also needs an x squared. But notice, so this will get rid of the fraction here, but over here for this first term, I will still end up with 7x squared over x to the 4th. If I reduce that, that becomes 7 over x squared. So I still need to get rid of some more x squares, so I'm going to multiply again by x squared. And we can see that if I multiply by x to the 4th, then the x to the 4th in the denominator will go away. So I think we found our LCD cannot just be x squared, but it needs to be another x squared, because I need x squared times x squared or x to the 4th. So this is my LCD. We will know if this is a true LCD if we multiply every single fraction, every single term, by our LCD. So here's my first term, and I'm multiplying it times x to the 4th power. Since it's a fraction, I'm going to multiply it by another fraction, and we can see how I multiply top times top, bottom times bottom, and I get 7x to the 4th over x to the 4th. The x to the 4th will cancel, and I just get 7. So that worked for this one. There's no more denominator. Let's come to the second fraction. Our second fraction was 8 over x squared. We're going to multiply by x to the 4th over 1, because fractions only multiply with other fractions. 8 times x to the 4th is 8x to the 4th, and at the bottom, x squared times 1 is x squared. So we can see how we can simplify this as 8 times x squared. That's this term right here. And again, no more denominator. So it's working. Let's see what happens when we multiply it times 1. Well, x to the 4th times 1 is just x to the 4th. There's no fraction there. So we have found that it's working continuously here. And then I have 0 here that still needs to be multiplied by x to the 4th, which will equal to 0. No more fractions. So this is now our new equation that we need to solve. In order to solve for x, the next thing I'm going to do is rewrite this in descending order. In other words, x to the 4th will be first, then my x squared, and then my constant, and then equals to 0. So let's talk about how do we solve something that looks like this, since we haven't done that before. Well, what we can do is that there's a relationship between x squared and x to the 4th. If we squared x squared, we get x to the 4th. So believe it or not, this is what we consider quadratic-like. Quadratic-like means that I can write this as a quadratic equation if I use u substitution. So in other words, I'm going to let u equal to x squared. It's always going to be this term here, not the 8, just the term that has the x's in it. So I'm going to get my x squared and let u equal to x squared. So if I square my u and I square my x squared, that's how I get u squared is equal to x to the 4th. So that means I am going to change my equation so that I have x to the fourth, I'm going to write u squared. That's where this one came from. Then I'm going to have minus 8, and instead of writing x squared, I'm going to have minus 8u because x squared is equal to u. And then I still have my plus 7 is equal to 0. Now we should see that we have a quadratic equation that we should know how to solve. And I said that if you had something squared, you might want to think of factoring. So here are my factors. I'm going to let u minus 7 equal to 0. And you can see I have found u is equal to 7. I let u minus 1 equal to 0. And you can see I found u is equal to 1. But remember, I don't want to know what u is. I want to know what x is. So I actually have to change it back to the x's. So how do I change it back to the x's? Well, I change my u back to x squared. So that's where this x squared came from. Then I'm going to square root both sides, and that's how I get x. And don't forget, when you take the square root, you need plus or minus the square root of 7. So I do the same thing over here. I'm going to change that u back into x squared. Then I'm going to take the square root of both sides. And don't forget plus or minus. So I'm going to get x on the left, and on the right I'm going to get plus or minus the square root of 1, which is 1. So notice I have 4 answers. I have x is equal to a positive square root of 7 as well as a negative square root of 7. I have x is equal to a positive 1 as well as to a negative 1. Now let's go check with our domain restrictions. If I come back up here to our domain restrictions, the only restriction we had was x cannot equal to 0. We don't have x is equal to 0, but we do have it equal to these 4 values. So I put those in the solution set. That concludes this video.